Okay, so this is part 2 of the Unit 8 essay. And it says here, acids and bases. Four unknown solutions were analyzed in the lab and found to have the following pH. pH of 1, pH of 3, pH of 8, and pH of 13. Indicate the hydrogen ion concentration in each solution. Well, the pH is described as the hydrogen ion concentration, right? So this would be 1 times 10 to the negative 1 molar. Where'd I get that 1? From there. This is 1 times 10 to the negative 3 molar. I'm looking for your molar. You should be able to do this one and this one on your own. So next, indicate, hey, come on, autofocus for me, would you? Indicate the OH in each solution. Well, remember, this superscript plus the OH has to equal 14. So 1 times 10 to the negative 13 molar is the hydroxide ion concentration. And this would be 1 times 10 to the negative 11 molar, which would be the hydroxide ion concentration. And you should be able to do these two. Label each solution as acidic or basic. Go by the pH, whether it's acidic or basic. So here, pH lower than 7, this would be acidic. pH of 3, this would also be acidic. And you need to do the other two. Indicate the color of the litmus paper when placed into each solution. This you would get off of your unit sheet. Acids turn litmus paper red. Acids, red. Now, if the solutions are 0.1 molar HCl and 0.1 molar sodium hydroxide and 0.001 molar HI and 1 times 10 to the negative 6 potassium hydroxide, correctly label each solution. So, what you're basically doing is calculating the pH given the molar concentration of all of this already. So, this is 1 times 10 to the negative 1, so this would be your 0.1 molar HCl. Now, this is also an acid. How do I know? It starts with an H, so that gets rid of this one. And I have to bring that 1, 2, 3 back. There's my 3. So this must be 0.001, and this would be hydroiodic acid, iodine-ic acid. Oh, I forgot the M. Put a M in here, right down there. So that took care of this one. You need to figure out which base each one of you have over here. Turn the page. Now, up here, we're talking gas laws. So this page is on gas laws. I'm just going to do this one, you do the rest. So it says if 8 grams of O2, 14 grams of N2, 11 grams of CO2, and 4 grams of HE are placed into a flask, how many moles of each gas would be in the flask? How many total moles are in the flask? So we have to convert to moles. 8 grams of O2, I look on the periodic table, this weighs 32 grams per mole. The grams are going to cancel. I need to use my calculator. Oh, which is not here. Hold on, let me get my calculator. Where'd my calculator go? Where'd my calculator go? Okay, calculator. So I'm trying to hold this. So clear. 8 divided by 32, 0.25, so equals 0.25 moles of oxygen. And then it says 14 of N2, 14 grams of N2. Nitrogen weighs 14.01, but 2 of them would be 28.02. So calculator, 14 divided by 28.02, and I get 0.499. I'm going to do 0.5, so this equals 0.5 moles of N2. It says 11 grams of carbon dioxide, so 11 grams of CO2. Well, this is 32 plus 12.01 is, so on here, 32 plus 12.01, 44.01, 44.01 grams per mole. Remember, grams are going to cancel. So 11 divided by 44.01. Hopefully you already know what it is. This is also, it says 0.249, so this is also 0.25 moles. And it tells me 4 grams of helium. So 4 grams of helium. If we look on the periodic table, helium weighs, it's the second one, 2. Yeah, so 4 divided by 2. Oop. 4 cookies divided by 2 people. Everyone gets 2 cookies. So that is 2 moles of helium. How many total moles are in the flask? So 2 plus 0.25 plus 0.25 is 2.5. And another half is 3. How many total moles are in the flask? 3. Then it says calculate the mole fraction of each gas. The fraction of each gas out of the total. So this is 0.25 out of the total, 3. And this is 0.5 out of the total, 3. And you should be able to do the others. So 0.25 divided by 3, 0.25 divided by 3, I see it is 0.083 or 8.3%. 0.083, which is 8.3%. And what is 0.5? Half a cookie, and you have to share it with 3 people. Well, you only get 17. So 0.17 or 17%. Now here it says the total pressure in the flask is 760 millimeters of mercury. What's the partial pressure of each gas? So here, very similar to what we were doing in class, 760 is the total, but we only want 8.3% of that. So we're going to times it by 0.083. I convert my percentage to a decimal, multiply it out. So 0.083 times 760. Oh, wow. 0.083 times 760. And I get 63.08. So 63.08 millimeters of mercury, that amount of pressure, is due to the oxygen gas. Here I'm going to do 0.17 times 760. 0.17 times 760. 129.2. So 129.2 millimeters of mercury is due to the nitrogen gas. And then you will find out how much pressure from the carbon dioxide, how much pressure from the helium. And when you add all these up, these millimeters of mercury, they'll all add to the total, 760. It says here, convert each partial pressure to atmospheres. Show your work. Well, how many millimeters of mercury is in 1 atmosphere? 760 millimeters of mercury is actually 1 atmosphere, 1 ATM. So this is the conversion factor we're going to use. So how do I convert 63.08 millimeters of mercury? You guys know this. I can do the T and put mmHg down here. So 1 ATM is 760. So 1 divided by 760 times 63, which gives me 63.08 times 1. But then I'm divided by 760, and I get 0.83. Well, look at that. So this is how much? 0.083 atm. You can do the rest. Now it says, what's the total pressure in atmospheres in the flask? If the total pressure is 760 millimeters of mercury, the total pressure in the flask is 1 atm. We're just converting. What is the total volume? Include all gases of the flask at standard temperature and pressure. So we want to know the volume. So what is the volume of gas at standard temperature and pressure? Well, at standard temperature and pressure, the volume of 1 mole of any gas is 22.4. Well, 1 mole of any gas at STP equals 22.4 liters. So what would 3 moles be? And it doesn't matter any gas, so 22.4 times 3. 22.4 times 3, 67.2. 3 moles is 67.2 liters. Use this in questions 20 through 22, which will be another video. Bye.